Hi everyone, Easy Lecture channel welcomes you. I was searching for a paper which speaks about the usage of virtual reality in making the electronics and communication engineering students to learn that concept, and in this regard I have come across this paper. So VRSEMLAB, a low cost virtual reality system to illustrate complex concepts involving spatial relationships. This paper was published in the International Journal of Virtual Reality, and it is a very old paper published in the year 2001. So I have read this paper. Now I am going to share what I have read and about my perspective about this paper. Before going further, subscribe my channel Easy Lecture. Now let us go. So here the main objective of this paper is the electronics and communication engineering students, they find it very difficult to learn the concepts that involve in electronics and communication, and also the concepts related to semiconductor physics. The reason is the things are very abstract in nature because the electrons and other charge carriers and the formation of other things like a depletion region or the energy gap, they cannot be seen with the naked eye, with visual eye, whereas so this make these things, these concepts to be very abstract in nature. But if these things are presented to the learners virtually, and if they are able to see the things, or if they are able to feel or experience the things, it will be very easy for them to understand these concepts. And in this regard, they have created an experiment by creating a model called Virtual Reality Semiconductor Lab. The short form is given as VRSEMLAB, Virtual Reality Semiconductor Lab, in which the things which are abstract in nature, which cannot be seen through naked eye, they are presented in virtual reality, and the learners or the users, they are made to experience the entire thing very naturally in the virtual environment. So this is the main objective of this paper, and the reason to go for virtual reality is it is possible to interact with the environment through multiple senses, because virtual reality means they have a head mounted device, and the head mounted device, they wear it around the head, around the eye, and it gives 3 degrees of freedom or 6 degrees of freedom, which means wherever they turn their eye or wherever they turn their head, the environment prevails. So they can experience the environment as if it is happening in the real life, in the real environment. So it gives such a kind of immersiveness. Okay, and it is not only with respect to interaction only with the eyes. So they can interact with, yes, because stereoscopic audio, it gives more immersive experience, and they can interact with the virtual reality glove or other handheld devices with the environment. And what happens when they interact with these things, the gestures that are made by the users, it is captured, and for that gestures the response is provided by the VR system. So this is the very positive side of virtual reality environment. And the advantages, the other advantages that can be provided by virtual reality are cooperative learning, interactivity, self-paced learning, narrative building, and this is personalization, tailored to individual need or learning style, means personalization, and distance interactivity. So my focus is on creating a personalized virtual reality environment for the learners or for the users to interact. So this is my focus. So let us see what the authors have done with respect to this experiment. So they have created the virtual reality semiconductor laboratory, and the reason is the students find it difficult to visualize the abstract concepts involved in semiconductor devices and electronics and communication. So here, because they are unable to view this Brillouin zone, energy momentum diagrams, depletion layer formation, so these things can be viewed in virtual reality. So they have created this virtual reality semiconductor lab in which all these things can be viewed by the users. So here what happens, the viewers, they wear head mounted device, and in the head mounted device there appears a big hall. They enter into the hall and they can see a large PN junction diode, and the PN junction diode, it has all the charge carriers. They can see them virtually from any angle, so they can move around the PN junction diode, that's particular semiconductor device, and they can view that from any angle. They can change the physical dimensions, they can change the other parameters of the device, and they can view what are the changes that are happening very dynamically. Okay, so even if it is under operation and if they make any change, immediately the change can be seen. Okay, so what are the changes they can see? So let us see. So here this diagram shows a big hall in which a big semiconductor device is there, a PN junction diode is there, but in this diagram it is not clearly mentioned which is N type and which is P type, but it is clearly mentioned through color differentiation that one is P type and another one is N type, and the bigger bubble indicate they are majority carriers and the smaller bubble indicate they are minority carriers. And the viewers, it is the view from the head mounted device, so that is the viewers, the user, they are seeing this. And to interact with the system, to interact with the environment, what happened, they have a virtual reality glove, and virtual reality glove means they wear the glove and they have all the sensors in it, and in the environment, in the virtual environment, the hand avatars are viewed. So hand avatars are designed. So hand avatars means it is a hand like graphical design. So whatever the gesture they make with the hand through virtual reality glove, that is depicted, that is reflected in the VR environment. So the same kind of movement or the same kind of gestures are produced by the hand avatars. Okay, so here what happens, this is the wall mounted provision to make the adjustment. They can adjust the physical, they can change, they can calibrate the physical dimensions such as doping level of the device, operating temperature and carrier mobility. So these things they can change, the users they can change, and to change this there are provision that in virtual wall the provision to change these things are mounted. Okay, so here is one example. Here there is a device control panel which is mounted in the virtual wall. So the users, they are using virtual glove to make changes, to make so here this is the virtual lever. They can change the virtual lever by making some movement or some gestures through their virtual reality glove, so that the hand avatars, they go to that virtual lever and they grab it, they make the adjustment, they make the calibration. So when such changes are made, immediately the changes are reflected in the virtual reality environment. So this is the kind of experiment they were doing, and it resulted in very good impact. So here this is the information panel mounted on the virtual wall. Okay, so here these are the system implementation. For the head mounted device, they used general reality cyber eye monoscopic head mounted display, and to simulate 3D perspectives they used depth cues. For hand glove, virtual reality hand glove, they used 5DT glove. To track the head and hand positions, they used polyhumous inside track magnetic tracking system, and the programming part was done by C language. So these are the things they used, and this is the scene graph, and using this device they have come to some discussion and conclusion. The thing is, the VR glove they used was one size fits all type. so that the hand of different users may vary in size. So if this happens, it raises the difficulty of finding the coordination of hand avatars in the virtual environment, so that raises to some kind of difficulty. And the animation or the virtual reality environment, they happen to be in the they happen in at the speed of 1.5 frames per second, which should be at least 15 frames per second, but this did not happen. As a result, there was not a kind of smooth movement. Okay, and so these are the things that they noticed. But again, this paper was published in the year 2001, but now we have a very advanced techniques, very advanced technology, in which we do not have to depend only on the virtual reality glove. We have other handheld devices, virtual reality handheld devices, so that anybody can operate by making the movement through by holding the handheld devices, so which is provided by a lot of head mounted display or virtual reality providing companies such as HTC Vive or Oculus or Tobii. So they provide a lot of things. And here, since it happened around 22 years back, 20 years back, the speed of the environment was happened to be 1.5 frames per second, but now we are able to create the environment in Unity, which happens at the rate of 100 frames per second. So this kind of possibilities are there nowadays. So all the difficulties that they faced in that time can be overcome very easily here. But now we have the biggest challenge. The thing is, this can be further extend to catching the eye position of the user, so where they are looking and where they are gazing, so at what duration they are looking at that particular point. So these features can be extracted through eye tracker. So this is what we can do further. These are the references. And he is one of the authors. Here is another author. Okay, so in this series about my reading, I will again meet you with another kind of paper. Until then, bye. Don't forget to subscribe my channel Easy Lecture. Meet you again soon. Bye.